Let's look at the globe down its axis from the North Pole. From this perspective, we see the Earth is rotating counterclockwise around the North Pole. How long does it take the Earth to make one complete rotation around its axis? 1 day. A more detailed explanation of our definition of a day can be found at the end of this video. How long does it take the Earth to make one complete orbit around the Sun? 365 1/4 days, otherwise known as 1 year. Every 4 years we have a leap year where we add an additional day in February to make up for the 4 extra quarter days. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical eccentricity. The Sun is not the center of the ellipse, but one of the focal points. Therefore, the Earth is a little closer to the Sun every January and a little further away every July. This eccentricity does increase and decrease slightly on a 100,000-year cycle, but for our discussion, the time of that cycle is too large to make a difference when discussing seasons within a single year. Thus, we can assume the eccentricity is fixed. Is the eccentric orbit the cause of the seasons? Let's think about that. We'd expect the planet to be a bit warmer overall when we're closer to the Sun. When does that happen? January. Is that the warmest season in the northern hemisphere? No. It is, however, the warmest season in the southern hemisphere. The seasons in each hemisphere happen at opposite times of the year. Thus, the seasons have to be caused by something entirely different than how close or far away we are from the Sun. Notice that the axis of rotation is tilted 23.5 degrees relative to Earth's orbit around the Sun. As the Earth orbits the Sun, the axis maintains its tilt at the same angle and the same direction relative to the orbital plane. Around June 21st, on a day known as the June solstice, the tilt causes the North Pole to face towards the Sun, while the South Pole faces away. The northern hemisphere receives the highest amount of sunlight, and thus it's summer there. The southern hemisphere experiences the opposite. It is facing away from the Sun and thus receives the least amount of sunlight of its yearly orbit, and thus it's winter in the southern hemisphere on the same days that it's summer in the northern hemisphere. When Earth's orbit takes it all the way around to the December solstice, which is approximately December 21st, the North Pole is now tilted away from the Sun and the South Pole tilted towards. The northern hemisphere experiences winter, while the southern hemisphere experiences the opposite season, summer. The North Pole is facing away from the Sun and gets less overall sunlight. The South Pole is facing towards the Sun and gets more. Thus, we see that seasons are caused by the axial tilt of the Earth as it orbits the Sun. To explore this more fully, let's look closely at how the Sun's rays hit the Earth. As Earth moves towards the December solstice, the North Pole faces further and further away from the Sun. On solstice day, the axial tilt puts the North Pole in a position where every location within the Arctic Circle is facing away from the Sun all day and receives no sunlight, 24 hours of darkness. Note, this day is a wonderful time to visit the Arctic Circle if you want to see the brightest aurora borealis, northern lights. Key locations north of the Arctic Circle include northern Norway, Sweden, and Finland, Greenland, Canada, Alaska, and Russia. People who live in these places will receive 24 hours of darkness for potentially many weeks before and after the solstice. Meanwhile, notice what happens in the southern hemisphere. Every location within the Antarctic Circle is always facing the Sun and thus is getting 24 hours of sunlight. Almost every location south of the Antarctic Circle is on the continent of Antarctica, and thus these are very difficult places to travel to. But if you could travel there, it might be difficult to know when to sleep as it's light all day. On this same day, the Sun's rays hit directly at the latitude of 23.5 degrees south of the equator, a location called the Tropic of Capricorn, which runs through a number of countries in South America and Africa, as well as Australia. Travel to one of these locations to experience the most intense direct sunlight on this day at solar noon with no shadow. As we watch the Earth continue to orbit, it reaches a location halfway between the December and June solstices around March 22nd, when the Earth's axis lines up so that neither pole faces away or towards the Sun. As the Earth rotates every 24 hours, each area of Earth's surface will spend 12 hours in view of the Sun and 12 hours out of sight of the Sun. 12 hours of day, 12 hours of night. Equal lengths of day and night is why we call this day an equinox. As the Sun's rays hit the surface, they are strongest at the equator directly in the middle, where they hit at a 90-degree angle. That's where sunlight will be most intense, and at solar noon, when the Sun is directly overhead, there will be no shadow produced. The equator runs through a number of countries in South America and Africa, as well as across the oceans in places like the Maldives, Indonesia, and the Galapagos Islands. Travel to one of these locations on an equinox to experience direct sunlight at solar noon with no shadow. Continuing our orbit, we move towards the June solstice, where the North Pole will be fully tilted toward and facing the Sun. As we move closer to that position, the North Pole receives more and more hours of sunlight each day. When we reach the solstice, the Northern Hemisphere experiences summer. All points within the Arctic Circle experience 24 hours of sunlight, and the Sun is directly overhead, providing its most intense heating at the Tropic of Cancer, at a latitude of 23.5 degrees north of the equator. The Tropic of Cancer runs through Mexico, the Bahamas, Northern Africa, the Saudi Peninsula, India, Bangladesh, and Myanmar, southern China, and Taiwan. Travel to one of these locations to experience the most intense direct sunlight on this day at solar noon with no shadow. The position of the axial tilt on the June solstice creates the summer season for the northern hemisphere and the winter season for the southern hemisphere. As we watch the Earth continue its orbit, notice that Earth's axis lines up again so neither pole faces away or towards the Sun during the September equinox. On this day, all parts of the planet receive equal amounts of sunlight and darkness. The equator receives direct sunlight, and at high noon the Sun would be directly overhead and no shadow would be produced. This marks one complete year of seasons, and as the Earth continues in its orbit, we will continue to cycle year after year through these same seasonal changes. Pause now. You have now reached the end of the explanation of the cause of the seasons. Continue on if you'd like to learn more about the definition of a day and how Earth's tilt changes over tens of thousands of years. Earth rotates around its own axis once every 23 hours and 56 minutes. We add another 4 minutes more rotation because during that time, the Earth has moved 1 day of its annual orbit around the Sun, which puts the Earth in a new position relative to the Sun. The extra 4 minutes allow the Earth to catch up and ensure we face the Sun at midday throughout the year. Multiply 4 minutes per day by half a year or 6 months, and you get about 12 hours. Thus, after 6 months of Earth's orbit, which puts us on the opposite side of the Sun, we'll have added a total of 12 hours more rotation, which means we are still facing the Sun at noon. We don't notice this 12-hour rotation unless we look at the stars in the sky, the fixed objects against which we can see our motion, which is why we see different constellations at night depending on the time of the year. Does Earth's axial tilt really stay permanently fixed at the same angle, 23.5 degrees? On a many hundred-year timeline, yes, but over tens of thousands of years, no. Every 41,000 years, Earth's axial tilt, its obliquity, cycles back and forth between 22.1 and 24.5 degrees with respect to Earth's orbital plane. The greater Earth's axial tilt angle, the more extreme our seasons will be, As each hemisphere receives more solar radiation during its summer, when the hemisphere is tilted towards the sun, and less during the winter when it's tilted away. Go back in time 10,250 years, and Earth would have tilted 24.5 degrees, and seasons would have been more pronounced. Go forward 10,250 years, and it will tilt 22.1 degrees, and seasons will be slightly less pronounced. Does Earth's axial tilt really stay permanently fixed at the same position relative to the stars? Does the North Geographic Pole always point at the star Polaris like it does today? On a many hundred-year timeline, yes, but over tens of thousands of years, no. Earth's axis precesses like a wobbling, spinning toy top. The axis that points out the top traces a slow circle over time. It takes 26,000 years for the precession to bring it back to a particular position. That means that 13,000 years ago, the North Pole would have been facing towards the sun in December, and the seasons would have been flipped. When scientists discuss natural phenomena, we have to consider multiple timescales. For explanations that relate to what's happening around us today, we use the timescales of our lives: seconds, minutes, hours, years, and generations, hundreds of years. When we look into the past and want to discuss natural changes that have occurred on our planet that brought us to where we are today, then we look into timescales of thousands of years, hundreds of thousands of years, millions of years, and even billions of years. For more information on these topics, look to additional videos found in the Earth Rocks collection.